Hello, I just got up. It is 11 in the morning at my time. One of my friends just shared this and great. She is learning to be a programmer. So I guess the article is about coding. I would like to join reading with her. The note said timeout function. Knowing how to construct a promise is useful, but most of the time, knowing how to consume or use promises will be key. Rather than constructing promises, you'll be handling promise objects returned to you as the result of an as I don't know how to read it asynchronous operation. These promises will be start or pending but settle eventually. Moving forward, we'll be stimulating this by providing you with functions that return promises which settle after some time. To accomplish this, we'll be using setTimeout. In bracket, setTimeout is a Node API. A comparable API is provided by web browsers that uses callback functions to schedule tasks to be performed after a delay. setTimeout has two parameters, a callback function and a delay in millisecond, right? Milliseconds. I'm not sure what about this. And then the picture of the coding. Here we invoke setTimeout with the callback function delay hello and 2000 in at least 2 seconds. Delay hello will be invoked, but why is it at least 2 seconds and not exactly 2 seconds? This delay is performed asynchronously. The rest of our program won't stop executing during the delay. Asynchronous JavaScript uses something called the event loop. After 2 seconds, delay hello is added to a line of code waiting to be run. Before it can run, any synchronous code from the program will run. Next, any code in front of it in the line will run. This means it might be more than 2 seconds before delay hello is actually executed. Consuming promises. The initial state of an synchronous promise is pending, but we have a guarantee that it will be settled, not be it will settle. I read adding up the word. How do we tell what computer what should happen then? Promise objects come with an aptly named then method. It allows us to say, I have a promise when it settles. Then here's what I want to happen. In the case of our dishwasher promise, the dishwasher will run then. If our promise rejects, this means we have dirty dishes and we are soaked and run the dishwasher again. If our promise fulfills, this means we have clean dishes and we put the dishes away. Then is a higher order function. It takes two callback functions as arguments. We refer to these callbacks as handlers. When the promise settles, the appropriate handler will be invoked with that settled value. The first handler, sometimes called unfulfilled, is a success handler and it should contain the logic for the promise resolving. The second handler, sometimes called unrejected, is a failure handler and it should contain the logic for the promise rejecting. We can invoke then with one both on neither handle. This allows for flexibility, but it can also make for tricky debugging. If the appropriate handler is not provided instead of throwing an error, then we'll just return a promise with the same settle value as the promise is was called on. One important feature of then is that it always returns a promise. We'll return to these in more detail in a later exercise and explore why it's so important. And this is the image that she talked about how the dishwasher runs. I like the image, but I don't understand the article I just read. Review. Awesome job! Promises are a difficult concept even for experienced developers, so pat yourself on the back. You've learned a ton about synchronous JavaScript and promises. Let's review. Promises are JavaScript objects that represent the eventual result of asynchronous operations. Promises can be in one of three states: pending, resolved, or rejected. A promise is settled if it is either resolved or rejected. We construct a promise by using the new keyword and passing an executor function to the promise constructor method. setTimeout is a not function which delays the execution of a callback function using the event loop. We used then with a success handler callback containing the logic for what should happen if a promise resolves. We used catch with a failure handler callback containing the logic for what should happen if a promise rejects. Promise composition enables us to write complex, synchronous code that's still readable. We do this by chaining multiple thens and catches. To use promise composition correctly, we have to remember the return. To use promise composition correctly, we have to remember to return promises constructed within a then. We should change multiple promises rather than nesting them. To take advantage of concurrency, we can use promise.all. That is all about reading English. Thank you. Have a good day. Bye.